In this video, still on electrostatics, so we're going to be solving a different problem this time. Okay, the problem is on the board and it says 2-point charges are located as shown in the figure below. Okay, now what the question wants us to do is to calculate the force that is being acted on both charges, okay, in terms of coordinates of free space. I was so lazy to write the question out, so I just had to read it. Okay, that's what the question said we should find. I'm also going to write a question in the video's description in case you didn't get what I said clearly. Okay, so we have to find the force that is being experienced by each of these charges in terms of coordinate of free space. So the charge experienced, of course, we know the charge is going to be equal, okay, because of Newton's third law. Okay, but they just want us to find the force that this one will experience depending on the location, that is in terms of the direction and all that. And then for these three micro coulombs, we're also going to do the same. So you see a problem like this, how then do you attempt it? Are you just going to find the distance between them and then find a single force? You could as well do that, it will be correct, it won't be wrong if you do that. But then again, if you do that, how are you then going to put it in terms of vectors after all? That is where most persons find it confusing. Okay, so the first thing I'm going to do, remember the force remains the same, the formula for calculating it remains the same. If you don't know how to solve questions using Coulomb's formula or Coulomb's law formula, what you might want to do is watch our previous video on the explanations and the problem we attempted, a very easy problem, and then you can come back to get a full understanding on this one. Okay, now the formula remains F is equal to K Q1, okay, times Q2 divided by the square of their distance apart. Now, don't make the mistake of adding this 175 as the total distance apart. Rather, the distance we need is the shortest distance between the two charges. When you add 175, you get 175, which is a whole lot bigger than the distance between these two. Okay, so if I'm to find the distance between, in fact, let's bring out this diagram. Let's bring out a free body diagram. So imagine we're having the free body diagram of this one, okay, something like this. Okay, we're having one charge here and another one here. Okay, it gave us here 75 centimeters, 100 centimeter. What will be the value of this one here? Okay, that's the distance apart. To do that, we make use of our Pythagoras theorem. If here is y, let's call it y, then y will be equal to square root of 75 squared plus 100 squared. Okay, then y is equal to, now let's work that out. Okay, let's say we're having square root of 75 squared plus 100 squared. What are we going to get? We're going to get a value of 125 centimeters. Okay, so we're going to get 125 centimeters, which can be put in meters. Remember, we have to work with meter. So putting it in meter divided by 100, that will give you 1.25 meter. Okay, that's what we're going to get, 1.25 meters. Okay, so the distance between the 2 microcoulomb and the 3 microcoulomb charge is 1.25. So we succeeded in getting the value for R. Okay, that's quite easy. We've gotten the value for R. Okay, now the next thing you want to do is find the force of attraction between these two. Okay, so we're going to find the force of attraction using the formula F is equal to they did not really specify if it was in free space, but we're going to assume it was in free space. Okay, or maybe I left it out in the question where I decided to skip writing it. Okay, so we're going to get F is equal to 9 times 10 to the power of 9, okay, times the magnitude of, anyone could be Q1, let's call this Q1 in this case, and let's call this Q2. Okay, so 9 times 10 to the power of 9 times, what is Q1? We have plus 2 times 10 to the power of minus 6. Always remember to include the micro. Okay, in this case, could be anyone, could have pico, which is 10 to the power of minus 12, and any value. Okay, but most times expect them to be in micro or sometimes nano. Okay, and then multiply by the other value of the charge, which is plus 3 times 10 to the power of minus 6, okay, divided by the square of the distance apart, which is 1.25 squared. Okay, so when we solve for the force, what are we going to get? We're going to get 9 times 10 to the power of 9, okay, times 2 times 3 times 10 to the power of minus 12 divided by 1.25 squared. Okay, we're going to get a value for the force of 0.03456 newtons. Such a small force. Okay, so we get 0.0345 newtons as our answer by solving this, okay, using a calculator. That's what we're going to get. Okay, so the force F1, if the force experienced by this one is F1, okay, and the force experienced by this one is F2, they both have a value of 0.0356 newtons. So I'm not including the direction in this case. But the question then further asks us to calculate the direction of the force in terms of coordinates of free space. So I'm going to bring out this diagram again, and here's what I'm going to do this time. I'm going to have something like this, okay, for the charge Q1. It will experience a force coming from this direction. It will experience a force, okay, that will pull it that will push it in this direction due to this one. Okay, the force it's going to experience itself, we're going to call it F1. Okay, so I'm going to call the force let's call the force F1. Okay, the force is pulling it away. Okay, and then we'll have our normal diagram. Okay, and then we'll have another one here. Okay, this one is Q2, and then they are both positive, so they are moving away from each other. Now this one will experience a force F2 moving in this direction. Let's call it F2. Now here is where another problem comes in. How do we then find the coordinate? Because we don't know the angle between any of these and the direction of the lights. But we can do that if we choose to join these forces together using an imaginary line. Okay, by doing that we can find the angle. We know they are already perpendicular according to the diagram given. So here's 90. Now we don't know the angle here. Let's just call the angle here theta, and let's call here phi. Okay, that's what we're going to do. So here is Q1. Let me write it so that it can be bold. And then we are going to call here Q1. This Q1, this Q2 rather. Okay. Now we already know the value of F, but we don't need F to find the angles. I think we don't need that. Okay. What you want to do is find the angles using your normal geometry. Here is 75, here is 100. So here remains 75, here remains 100. I'm neglecting the units in this case because we don't really need it to find the angles. And then we'll have here as 125 in centimeters. Okay, I'm putting it in the same units. Assuming I was to use 1.25, I would have as well used 1 meter here, and then here I'll use 0.75 meter. That's how it will work. Okay. So what next? We want to find the angle. What will be the angle here? We could use any of these sides to find the angle, or we could make it easier. How about we find the sine of theta, the cosine of theta, the sine of phi, and the cosine of phi as well. So avoid unnecessary angles or decimals that will that might change our answer a little bit, because I can see we're going to go a very long way from here. So I think that would be better. Let's find the value of sine theta instead. Okay, so whenever you take the value of sine theta for a case like this, sine theta is what? Opposite of our hypotenuse. So here is the opposite. We have opposite over your hypotenuse. I think this reduces to what? 5 in 100, that's 20. 5 in 125. Let's do the maths. 5 in 125, that's 2 into 15. Is that 20 over 20? Let's just be sure. To avoid making any errors, because if you make any error in the beginning, it's going to affect your final answer, and after solving you probably be having issues. So 100 divided by 125, we're going to get 4 over 5. Like I said, there's an error. We're going to get what did I just call? So get an answer of 4 over 5. So I wonder where the issue was. Probably this should be 25. I think this should be 25, not 23. Okay, 25. Okay, for us to get 4 over 5. So sine of theta is 4 over 5. Okay, that's what we're going to work with. How about the cosine of theta? Okay, how about the cosine of theta? To get the cosine of theta, that's adjacent to hypotenuse. In this case, you have 75 over 125. Okay, when you do the math, 75 divided by 125, you get a value of 3 over 5. 3 over 5, that's what you're going to get. And then how about for phi? So notice that sine phi is equal to sine phi will be equal to, that's opposite of hypotenuse. So we have opposite here over hypotenuse, right? That's 75 over 125. 75 over 125. You notice the same thing as cos theta. So that's 3 over 5 here. And then obviously sine theta should be cos phi rather. Okay, cos phi should be same as sine theta. Okay, because cos phi is adjacent to hypotenuse. 100 over 125. That should give you 4 over 5. Okay, so that's 100 over 125, which is 4 over 5. Will it really work that way while resolving? Because, okay, I think we might still have to find the angles though, because we'll have to resolve from here down to the positive x-axis, resolve from here down to the positive x-axis. So I think in the end we might still have to find these angles. Oh, what a waste of time. Okay, so I'll just take this off. I'll take this off and solve for the angles directly. Let's find the value of theta. So to find the value of theta, we'll take the sine inverse of 4 over 5. That gives us 53.13. So theta is equal to 53.13 degrees. And then to find phi, we could as well use sine again. So sine phi is equal to opposite 75 over 125. So take the sine inverse of 75 over 125. Okay, 75 divided by 125. What you get is 36.87 approximately. So phi is equal to 36.87 degrees approximately. Okay, now the truth is that not like we're actually going to get something different. We try to work with sine, cosine, and phi, but we'll have to make a little change. Okay, in this case we're going to put the force here. Okay, or we can take this one and bring it here, and take the other one and bring it here. I think that will give you the same value. Okay, we have to bring it into the coordinates whereby we have the angles. Okay, but in this case we have to resolve down to the positive x-axis and the positive y-axis as well. Okay, that's what's going to happen. So let's proceed to solving for the force in terms of their coordinate of free space. Okay, that's what we're going to do next. So for F1, we want to write F1 in terms of its coordinates of free space. Okay, so for F1, it's going to be resolving F1 down to the positive y-axis, which is from here to here, and also from here to the positive x-axis. And then for F2, we're resolving from here to here, positive y-axis, and also from here to here, positive x-axis. Okay, now if you're very good with your resolution of forces, you might as well want to use the negative side. Okay, if you use those parts, definitely are going to get the same answer. Okay, but if you know you're not too good with that, I'm not going to stress you with it by doing it on this video. Maybe a different video on vectors, which is on mechanics. Okay, I'll do those ones. But here I just want us to be straight and then resolve everything. Take everything to your positive. If you are resolving, always make use of your positive axis. Okay, positive y, positive x. It will avoid avoid the chances of you making mistakes. And then it is after you get good, you see to start resolving to other axis as well, like negative x and negative y axis. So in this case, I'm using only the positive. So for F1, let's resolve to the positive x axis. Okay, let's get F1 of x, that is to the positive axis. What are we going to get? What am I going to get by resolving to the positive x axis? Now, resolving F1 to the positive x axis, we need to know the angle first. So here is theta. Okay, it means the vertically opposite angle to it is also what now? Theta. Okay, so the angle between the force and the positive y-axis is what now? Theta. Okay, so to resolve it to the x-axis, we're going to add the angle 90 degrees, which is on this part. So we have theta plus 90 degrees, that becomes our new angle. So resolving to the positive x-axis, we're going to get F1 cosine of, we're going to get F1 cosine of theta plus 90 degrees. Now this is not something you should cram, please take notes. What you should do is draw this diagram. Okay, if this one is not that clear, make it bold on your own working sheet. Don't cram theta plus 90 degrees, that's what you do in cases like this. No. Okay, we could have different scenarios of problems like this. So what you should take note is the angle here, I just did a little math. Okay, the angle here is opposite it directly, that's theta, and I'm resolving to the x-axis. So I need to make use of the total angle down to the x-axis, okay, which I just did, which is theta plus 90 degrees. Okay, and that will give me a value of what is F1 and F2, they are both equal, having a value of 0.03456. Okay, so we have 0.03456 cosine of what is theta. Theta in this case was given as 53.13 degrees, 53.13 degrees plus 90 degrees. Okay, 90 degrees. So when you solve for that, what you're going to get is a value of, okay, we have 0.03456 cosine 53.13 plus 90. Okay, we got a value of minus 0.027. Okay, we had a value of minus 0.0276. Okay, we are resolving in the x-axis, so that's the ij components. Okay, x corresponds to I, so we are going to have the I component. Okay, so this same thing as writing our value as minus 2.7612 times 10 to the power of minus 2I. Okay, that's for the I or the x-axis. Now for the positive y-axis, for this one we're going to resolve to the y-axis, which is just resolving here down to the vertical component. Okay, this is the y-axis. Okay, by doing that we resolve this one directly here, so that will be f1, still closing. Please scrap out any thing you've learned telling you that when resolving to the vertical is sine and the horizontal is cosine. Okay, please scrap those things out. You need vectors, you need an understanding of vectors to know how to resolve these issues. Okay, so if you're having any problem, feel free to check our videos on vectors and learn new things on vectors before you might proceed down to learning these things. Okay, as it will help you understand it better. Okay, so resolving to the y-axis, we're going to have f1 cosine of just theta. Okay, between here and here, we're going to have f1 cosine of theta. I could as well make use of some trigonometrical identities to solve this depending on the value I had there, but I'm not going to stress your learning with that at all. I'm just going to go direct. So I'll get a value of 0.03456 cosine of theta is 53.13 degrees. So that'll give me a value of 0.03456 cosine of 53.13 degrees. So I'll get a value of 0.0207. Okay, how many decimal places? 1 2 3 4, 1 2 3 4. Okay, I think that looks better. Okay, what else? This should be j. Okay, j. Okay, because this one is for the y-axis, and this could as well be written as 2.07 times 10 to the power of minus 2j. Okay, so in terms of coordinate of free space, charge q1, okay, for charge q1, it will experience a force of these two. Okay, in terms of coordinates of free space, I first followed by j. So charge q1 is going to experience the force, which is f1, and that is equal to what is what is the force here? So we had minus 2.76. okay, we can just keep the 10 to the power of minus 1 and bring it after joining it. So this is I plus 2.07, this is j, okay, times 10 to the power of minus 2. That's the force experienced by charge q1 in terms of coordinate of free space as required by the question. Okay, you can as well open it to get these values directly, okay, depending on what you want or what suits you or what is given in the examination options. Okay, and then for charge q2, we're going to start, come to charge q2. For charge q2, what you might notice is we most likely might not need to solve for charge q2, okay, because charge q2 is same as charge q1. Okay, the only thing is that it is opposite in direction. So instead of having a minus here, I'll have a plus here, and a plus here, I'll have a minus here, and every other thing might change depending on the I and j might also switch. Okay, that is what is going to happen. But let's just still solve and see to prove that I'm not wrong. Okay, now let's solve for charge q2. Okay, to solve for charge q2, you have to resolve f2 to the positive x and positive y axis. So to do that, we have f2x. Okay, resolving f2x. The angle here is phi. The angle here is phi, and we want to resolve from here down to here. How we're going to do that? Now, if here is phi, here is also phi. Okay, so the distance from this force down to the x-axis is still 60 minus phi. Okay, because we're moving that angle, we're going this way. Okay, you can choose to go this way, which will be f2 cosine of phi. That's what you're going to get. Okay, but to avoid the problems you encounter while dealing with trigonometry, if you're not that good with it, let's just go with the normal method like I said initially. So I'm going to have f2 cosine of 360 minus phi. So we're going to have f2, cosine of 360 degrees minus phi. Now this gives us, what is f2? Still 0.03456 cosine of 360 degrees minus, what is phi? We have phi as 36.87, so have 36.87 degrees. Okay, now when you do that on your calculator, you should get a value of 0.03456 cosine of 360 minus 36.87 degrees. Okay, that will give you a value of 0.0276. Okay, 0.0276. Now this one is for the x-axis, so I'm going to have I attached to it. Okay, that will be the value, or we can simply write it as 2.76 times 10 to the power of minus 2i. Okay, you could get that. And then for the other one, f2y, we are going to have resolving down to the y-axis instead. So in this case, here is, we are resolving down to this axis. So from here to here is 90, here to here is that's 180, here to here that's 270. So it become 217 minus 5. Okay, so this becomes f2 cosine of 270 degrees minus 5. Okay, when you do that, you get 0.03456 cosine of 270 degrees minus 36.87 degrees. Okay, what is going to be our value for that? So we have 0.03456 cosine of 270 minus 36.87 degrees. Okay, and that will give a value of minus 0.0207, okay, j, or this can be written as minus 2.07 times 10 to the power of minus 2j. Okay, so for F1 or charge Q2, let me get a different marker. Okay, so for charge Q2, we are going to have F1 to equal the sum of these two. Okay, so F1 then becomes, remember, I can put the 10 to the power of minus 2 outside of the bracket. So I'm going to have 2.76i minus 2.07j times 10 to the power of minus 2. So in terms of coordinate of free space, Q2 we have this value, okay, and then Q1 is going to have what now? Here's the value. Q1 is going to have this value, okay. So that is the simple tricks to solving problems like this. Remember, F1 and F2 they are equal. Now, what you notice that the magnitude, when I take the magnitude of this answer here, that is the square root of minus 2.76 squared plus 2.07 squared, and I take the square root of the sum of the squares of these ones, I will get the same value of F1, which is 0.03456. That's what I'm going to get. And when I do this for Q2, when I take this one squared, I'm going to get what now? The same value as well, which is that one that is up there. Okay, what you can note from this result is that F1 and F2, they are the same, just that they are opposite in direction, just the same way you are seeing it in this free body diagram. Okay, so the force experienced by F1 and F2, they are the same. Okay, the only thing is that they are opposite in what now direction, which is in accordance with Newton's third law. So it is quite easy. If you did not get it, like I said, vector might be the issue or the problem why you might not understand it. So what you might want to do is watch our videos on vector when we treated the resolution of vectors. Okay, and then you can come back to start playing with these problems, and trust me, they are very easy. Now, next few videos, we're still going to solve a different exercise that is quite different from this one, but we might still need a few understanding on this, okay, I have to take them step by step. Okay, so that is how it is being done. Do it to like, share with your friends. If you have a question, put it in the comment section. If you have a video you'd like us to talk about, put it in the comment section as well. Okay, in our next video I'll try my possible best to answer your questions. Okay, I know that you guys actually needed it. Don't forget to subscribe to the channel, Dr. Flash. Click on it right now as I'm looking at you. Click on that subscribe button. Okay, don't wait. Click on it. Okay, don't forget to do that, and then click on the notification bell so that when new videos is being uploaded, as usual, you get notified. Okay, you'll be one of the first persons to enjoy the benefits of these videos that are being created. So see you in the next video. Stay tuned. Bye bye.